All right, hi guys. We're gonna go over the 7.2 homework and wanted to talk about it with you guys a little bit. So, first part, we started some of this in class, but we talked about that the scenario that we're talking about, they give you one with an Empire State Building and saying that it's about 1,454 feet tall. How long do you think it would take a penny drop from the top to hit the ground? So you could have a bunch of estimations there saying like, I think it'll be 10 seconds, 11, whatever it is. But then we give it to a scenario with Galileo on the Leaning Tower of Pisa and was dropping different items, balls off of there. I don't know that they had bowling back then, but we'll say a bowling ball. And we're trying to figure out what each of the values are. Now, I have in there some of the values already. And for some of the classes, we started going through like, what is this? How did we get this? So in your calculator, I would have been typing in 1,600 minus 16 times, and then I'm plugging in each of those values. 0 squared is the first one. That's how I got 1,600. Then I do it for 1,600 minus 16, parentheses 1 squared. I hit enter, I get 1,584. Then I go down to, I keep doing this. I'll do one more. Let's say I'll do 8, or whoops, 1,600 minus 16 times 8 squared, and we get 576. So we could see that here with it of, down for 8, I have 576, 93040. So there's each of the values. I'll leave that there for just a second. You could pause it too as you go along, but it asked us to find each of those. Then it asked for number 3, why do negative values not make sense? Well, we're talking about dropping a ball off of the Leaning Tower of Pisa. Now, maybe you could say, like, well, it's going to make an indentation, possibly, whatever, depending on the mass of the ball. But negative domain values don't make sense. That would be the feet part. But as far as seconds, I can't have negative seconds. Okay, so I'm going to just put it in shorthand, but I can have no negative seconds that I'm talking about here. I know it looks a little bit different. Oh, there's the bell. It looks a little different here from your book because I printed it off of the internet version. Okay, now using the table, this I didn't do. I want us to go through together of, let's go through and graph this out. So of those pieces, I have 0 and 1,600. I'm going to double check. It looks like it's going up by hundreds. 1, 2, 3, 4, 5. Yes. So at 0 seconds, it's at 1,600 feet. Okay. At 1 second, it's at 1,584. You're estimating here. At 2 seconds, it's at 1,536. At 3 seconds, we're at 1,456. 36, sorry. At 3 seconds, or no, what am I looking at wrong? 3, 1456. I'm good. 4, 13. So there's 1,000, 11, 12, 13, and 44. At 5 seconds, we're exactly at 1,200. At 6 seconds, 1,024. 7 seconds, 800. So there's 1,900, 800, and just barely 816. 8 at 576. 9 at 304. 1, 2, 3, almost right on 300. And at 10 seconds, we're at 0. So as I look at that now, thinking like this, it didn't like flash through each of these points. This I could connect the dots on. I'm going to try to pretty closely, because there's time in between 0 and 1, 1 and 2, and so on with each of those seconds. So when we're looking at this, then now they're asking for reasonable domain and range. And when I think about what the domain is, well, it's only a limited amount of time. This isn't in all real numbers. It's not in all whole numbers. It started at 0 seconds. It ended at 10 seconds. Okay? It doesn't continue traveling through the ground going You know, they always like, if you dig a hole, you dig to China. It's not going to go all the way through there. So my domain is just between 0 and 10 seconds. So this is a domain that's an in-between one. The range, well, the lowest Y value is 0. The highest Y value is 1,600. So it's another one that's in between. It's between 0 and 1,600. Okay. Now, what's the y-intercept? Remember y-intercept, we want a coordinate. So it is crossing at that point, which is 0 and 1,600. What does the y-intercept represent? Well, that we're looking at, that's the point where we haven't dropped the ball yet. Okay, so when we're looking at it, it's that point of the height of the object. There we go. The height of the ball before it was dropped. So when it's, what does it represent? Remember, keep it simple. I'm going to write it as just that. The height of the object before it is dropped. Okay. All right, what's the x-intercept? Now, this one we haven't asked on a lot of them, but here's the x-intercept. It's at 10, 0. So when I write it down again as a coordinate, but I went right 10 and I didn't go up or down. Now, what does that represent? Well, it's representing when the ball reaches the ground, okay? Or I'm going to be more specific. I didn't write it very well there. The seconds, I keep writing SEO. I'm forgetting the C. The seconds it takes for the ball to hit the ground or reach the ground. Okay? All right, identify any extrema, max, mins, or relative max and mins. Well, this just has a high and a low point. So if I'm looking for extrema, it has a max of 1,600 and a min of 0. Now, what do they represent? Well, the first one we already said, it's the height of the object before it's dropped. Just going to kind of draw an arrow to there. What does the minimum represent? Okay, that's where the ball hits the ground. It's almost the same if that's how many seconds, but that's when the ball is on the ground. It's the lowest amount that it's going to reach. Okay. All right. Moving on, we get to number 10. Now, for number 10, I asked you specifically to use the points -2, -1, 0, 1, 2, and 3 for that new function, just x squared minus 2x. And this one says it's not limited by a real world situation. Hence, we get into some negatives. I would do the same thing calculator-wise, though, to plug into this first. Okay, so I'm going to do parentheses, -2, close parentheses, squared. That was -2 times x. In this case is, whoops, not -2, -2. So I get 8. And I do it again, parentheses, -1. Do one more. Make sure you're using the negative button down there. -1 squared minus 2 times -1, close parentheses, hit enter. You get 3. So you would keep going down with each of those, and I'd plug in 0, then I'd plug in 1, 2, and 3. And what we end up with these is we'd get 8 and 3. We did those two. Then we have 0, -1, 0, and 3. So those are our 5 values. And again, I asked you to use those x. Before you left, I said, please put in these x values. Now, I'm going to graph these again. At -2, I'm up at 8. At -1, go left 1, and I go up 1, 2, 3. I'm at 0, 0. 1 is at -1. There we go. 2 is at 0, and 3 is at 3. 1, 2, 3. There we go. Okay. And I'm going to actually sketch this out. I'll connect the dots. And you could see we said today it'd be parabola. Yesterday we worked at linear functions. They look like a line when we sketched them out. Okay. Then it says, all right, describe the differences between the domain of this one, which they didn't ask for yet. So let's just do, what is the domain and range? Well, the domain here, it does not have an X value starting point. These would keep on going up forever. If I'm drawing, you can't really see my fingers as well, but it'd go up forever, up forever. So this is one where our domain is all real numbers. It doesn't have a limit. It doesn't stop from 0 to 10 seconds. It's not a real world scenario. The range, while it does have a low y value, it's -1. So all the y values, though, it's at -1, and then they all go up from there. So I have y is greater than or equal to -1. Okay, so if I'm asking what's the differences between the domain from here and the real world, I could put some, keep it simple. This has all real numbers, and Galileo doesn't use negative values. That would work good. I'm looking what they have on the answer key. Pretty much the same thing. The domain of Galileo's function is limited to values of x that make sense in the real world situation, non-negative. It also stops at 10 seconds. Now, we already did the range here. Y is greater than or equal to -1, starts at -1 for the low point and goes up. Okay, identify the x or y-intercept, sorry. The y-intercept is going right through 0, 0. So remember, write it as a coordinate. And then almost there, last one. What is the absolute maximum of this function? Well, it keeps on going up forever. There is no absolute max. What's the absolute min? We're down there at -1. So for absolute max, I'm going to put none. I still need to put none. Don't leave it blank. And then for the absolute minimum, we're at -1. So still using all the same things we've been using. We're just applying it to ones that we're actually graphing out now. But it gives us, we're going to keep getting more and more practice on domain, range, min, max, y-intercept, x-intercept, all those good things. Okay? Guys, have a great day. We'll see you soon.